Of the 18 widely recognized loci in the field of dog coat color genetics, 3 stand out: the Agouti locus, the black locus, and the extension locus, commonly just referred to as the A, K, and E locus. These 3 loci are the ones mainly responsible for the placement of the 2 different pigments in dog coats, eumelanin and pheomelanin. If you've seen my first 2 videos in the series, you already have a pretty good understanding of all of these terms. If you haven't, go do that first, I can wait. And to those of you that have watched but need a brief refresher, here you go. If a dog's DNA is like a cookbook, genes are specific recipes for specific traits, like eye color or coat length. Alleles are simply different versions of those gene recipes, like having blue eyes specifically or a short-haired coat. A locus is the location of those genes within a strand of DNA. You can also think of them as categories that genes are sorted into. Genotype refers to the genetic information of a dog, and phenotype to the physical appearance. Genes come in pairs, one inherited from each parent, and one dominant gene in a pair is enough to be expressed, but 2 recessive genes are needed in order to be expressed. Lastly, dogs have 2 kinds of pigment: eumelanin, which is black-based, and pheomelanin, which is red-based. A dog's nose, eye, lip, nail, and paw pad color all come from eumelanin. White in dog coats are either a very light shade of pheomelanin or a lack of pigment entirely, resulting in pink skin underneath. In this video, I won't be explaining each of these 3 loci in detail, but rather how they interact with or override one another to create the overall phenotype of a dog. Don't worry, I will be posting individual explainers on A, K, and E soon, but you don't need to have seen them in order to understand this one. So, here's the hierarchy. Let's start with E. There are at least 6 distinct alleles at the E locus, and one of them is the recessive red gene. This gene pair will suppress eumelanin in the coat completely. Golden retrievers, yellow labs, and Irish setters are all good examples of this genotype. Their eumelanin base color is almost always black, as we can see in their nose and eyes, but there's no dark pigment in their coat, because the genes at the E locus has overridden whatever genes might be at A or K. Note that those genes still exist, they're just not being expressed in the dog's physical appearance. So, having mentioned the influence of the recessive red gene, most dogs actually have at least one dominant wild-type gene, which doesn't interfere with eumelanin at all, allowing genes at the A and K locus to be expressed normally. It might help to think of the E locus as a kind of on-off switch that asks, am I going to allow eumelanin to be expressed normally in the dog's coat? If the answer is yes, decisions about the dog's coat get passed on to the K locus. The K locus basically decides how much it's going to allow the A locus pattern to show through. There are 3 possibilities. The first is dominant black, which says make the whole coat eumelanin regardless of what A wants. The second is brindle, which says let's see what A says, and then we'll just put eumelanin stripes over that, so at least some of the patterning will be visible. The last option is non-black, which essentially is the K locus taking a complete backseat and saying, you know what, let's let the A locus decide what the coat will look like. Speaking of, you can think of the A locus as the designer locus. It decides where to put both eumelanin and pheomelanin to create specific patterns, like saddle tan or agouti or tan points. But it can only do this if E and K allow it to. Now, as I mentioned before, there are 18 loci in this field, not just these 3. And some of these can indeed affect a dog's appearance drastically. Genes at the S locus, for example, can cause really large white patches on a dog, meaning a total lack of either pigment. So the E, K, and A loci are by no means the full story of what makes up a dog's phenotype, but even the most complex stories still need a beginning, a middle, and an ending. And these 3 loci provide that foundation. After that, genes at the other loci can come in and insert the characters and plot points where they're relevant. As a side note, if you've used Dog Breeder Pro's genetic forecast feature by now, you might find yourself wondering, If the E locus is so important to a dog's phenotype and it can even override K and A, why isn't it one of the mandatory fields? The answer is simple. E is predictable and K and A aren't. This is because that dominant wild type allele I mentioned is by far the most common one found at the E locus, resulting in, well, nothing, because it wouldn't have an effect on the K and A locus. Remember when I said that E is kind of like an on and off switch? Well, most of the time, it's off. So, unless we're told explicitly otherwise, that is what we assume. There are, of course, breed exceptions like golden retrievers and Labradors, so it depends on what breed you personally are working with. I know dog genetics can be an intimidating field, especially when you start to venture past the basics and into all the exceptions and complexities, but that's what the series is for. And I hope that these concepts are becoming less daunting to you. And if you still haven't tried our platform, please go and start a free trial at dogbreederpro.com. There are so many cool features waiting for you. Thank you for watching, good luck, and bye!